In years past, I've not stopped and done this because I just kind of explained it in context, but because of our schedule this week and some other things going on, I think it's a good time for us to stop and review how you do algebraic and arithmetic operations with trig expressions. This is probably not something that you did before. I know you didn't do it in geometry, so you've not seen how these trig expressions and ratios work with each other. Now this is 2 sine x minus 1 times 3 sine x minus 4. What does your instinct tell you to do here? Foil it? Yeah, we're going to distribute it twice, but how do these things interact with each other? For example, what is 2 sine x times 3 sine x? 6 sine squared. Which is what squared, the sine or the x? The sine. Okay, so the way you write this is 6 times the sine squared of x. All right? The only other way that you could write that, and it's a little bit more cumbersome, is to write it as the sine of x squared. All right, but that's not going. You're not going to see that very often. You're going to see it like this: the sine squared of x. Okay, the angle we leave alone. The angle doesn't change. All right. Then we multiply 2 sine x times negative 4. That gives us negative 8 times the sine of x. Inside we get negative 3 times the sine of x. And then negative 1 times negative 4 is positive 4. And now the only thing that remains is to combine these two like terms in the inside, and we will get 6 times the sine squared of x minus 11 times the sine of x plus 4. Now tell me what that looks like. What does that look like from algebra? It looks like something that we would have factored, right? This looks like a quadratic expression. It looks like 6y squared minus 11y plus 4. All right, and it behaves a lot like this algebraically. That's it. This is in a quadratic form. It's not a quadratic expression per se. It's not a polynomial expression. It's a trigonometric expression. But we can treat it. It has a lot of the properties, algebraic properties of polynomials. All right. It'd be interesting maybe to look at the graph of this and the graph of that, see if there's any kind of relationship between them. And that's just off of the top of my head. I've never done it before, but I'm going to do it at some point today, just to see. All right. So that's what that expression would look like in a simplified version. All right. What about the next one here? Sine x minus 1 times sine x plus 1. What's the relationship of these two expressions? They're conjugates. And when you multiply conjugates, you get a difference of squares, right? So if we multiply sine x minus 1 times sine x plus 1, we're going to get sine squared x plus sine x minus sine x, no mas sine x, right? And then 1 times negative 1 is minus 1. So that's the expression there. Now, I do want you to expect that when you practice this, we're also going to take an expression like that and factor it. It's like y squared minus 1. How would you factor y squared minus 1? It's y plus 1 times y minus 1. We're going to go a little bit further in our trig factoring because we're going to go into some irrational, factoring things over irrational numbers. And I'll remind you of something that I showed you back in college algebra when we get to that point. All right, try this one on your own. Try this one. Okay, Javen, what'd you get? Well, why not? Daniel, what'd you get? He's sitting back there just chilling out. I thought he was done. Daniel, what'd you get, buddy? 6 cosine squared of x. You said plus cosine x minus 1 is correct. Because our inside and outside terms would be minus 2 cosine x plus 3 cosine x. 3 cosine x minus 2 cosine x is 1 cosine x. So we get 6 cosine squared x plus cosine x minus 1. And again, this is in a quadratic form, so we would factor it, if we were factoring it, the same way we would factor 6 cosine 6y squared plus y minus 1. All right? Let's see. I think you guys have got that. Let's look at what's next here. That's not very interesting. Try this one. We can work it together. Javen, we can work it together. You still look like you might not feel 100%. Well, I appreciate you coming here to get the rest of us sick. Well done, Javen. All right. Sine of x times 3 sine of x is 3 sine squared of x, right? Now, we've not seen anything like this yet. What is the sine of x times negative 4 cosine x? That's the question, right? It would be negative 4 sine x cosine x. Yes, sir. You can switch that order up. I just, because of the way some identities are written, I always put sine before cosine. It's a habit that I'm in a matter of doing. I would encourage you to always do the same order. But there's a prominent identity that we're going to learn that's important, sine x, cosine x. And even in that identity, the order is not important, but that's the way you'll memorize it. Cosine x times 3 sine x is 3 sine x cosine x, or cosine x sine x. And then cosine x times negative 4 is negative 4 cosine squared of x. And the reason that I wrote those over top of each other there is because I was running out of space, but also they're like terms that will be combined. So 4 sine x cosine x, negative 4 cosine x plus 3 sine x is negative 1 sine x cosine x minus 4 cosine squared x. Do what? No, this is what we're learning today. I mean, I don't know that you would have ever done this before. Have you ever multiplied and added trig expressions like this? Not unless you've had, pre-calculus but this is a skill that's confusing for folks. Now, this is not quadratic, but this looks a whole lot like something that you might have done along the way in your factoring expressions. This looks like 4x squared minus x times y minus 4y squared. We have two different variables in a quadratic-like expression. Okay, so that's what that one is going to look like. Let's see. This is the last one, and then we'll do some factoring, and then we're going to be out of time. All right, this one is similar to the last one. What's another way that I could have written this? Sine x minus cosine x squared, right? And you'll see that from time to time, and that's how we would have to write it. But this is already kind of in expanded form for us. So we will distribute here. Sine x times sine x is sine squared of x. Sine x times negative cosine x is negative sine x cosine x. Again, we get another one of those when we multiply there. And then cosine x times cosine x, negative times negative is positive cosine squared of x. So when we combine our like terms in the middle, we get sine squared of x. There's two of those, right? Minus 2 sine x cosine x plus cosine squared of x. All right? So that's that. Is over. Let's factor some things. Now, I want to kind of remind you of something, though. I told you last year, and some of you actually did this last semester, rather, which was last year. Some of you actually did this, that every difference is a difference of squares. So we can take something like x squared minus 2, and we can factor that as a difference of squares, right? What would the factorization of x squared minus 2 be? X plus, not 2, square root of 2 times x minus the square root of 2. Okay? No. Square root of 2 times the square root of 2 is 2. All right? Now, so we could go a little bit further. Y'all stay with me on this. Please stay with me. And we could look at something that looked like this. 4x squared minus 3. And we could factor that, right, as a difference of 2 squares. What's the square root of 4x squared? 2x. The square root of 3 is the square root of 3, right? So we could multiply this as 2x plus the square root of 3 times 2x minus the square root of 3. All right? Now, here's where this is going to come into play. Here's where this is going to come into play. If this were equal to 0, it becomes a quadratic equation, right? And then we would set each of these factors equal to 0, and we would get x equals negative square root of 3 over 2 or positive square root of 3 over 2 from these two solutions. Are y'all paying attention here? Yeah. Square root of 3 over 2 looks a whole lot like what? One of our trig ratios from one of our special right triangles, correct? So being able to take an expression like 4, you should be writing this down. 4 times the sine squared of x minus 3 equals 0. Being able to factor that as 2 sine x minus the square root of 3 times 2 sine x plus the square root of 3 equals 0. All right, and then we would be able to set each factor equal to 0, and we would get sine x equals, if you add the square root of 3 and divide by 2, you get positive square root of 3 over 2. And for this one, you would subtract square root of 3 and divide. So sine of x is plus or minus the square root of 3 over 2, and we could use that information and our table to find out what x is. Okay? Which angle has a sine value of square root of 3 over 2? It would be pi over 3, 60 degrees. And since it can be positive or negative, we can place that angle in all 4 quadrants. Okay? So we're looking at 4 solutions between 0 and 360 degrees for this particular trig equation. All right, so that's where this skill is going to be very important, learning to do this. Now, you wouldn't have to factor this that way, would you? You could also use what? The square root property? Right? Yeah. So you could add 3 to both sides, Javen? Yeah, I mean, Garrett, 4 sine squared x equals 3. Square root property, 2 sine of x equals plus or minus the square root of 3, and then divide by 2, because we're square rooting things, right? And the plus or minus comes into play from the square root property, absolute value of x. All right, and then, of course, again, sine x would be plus or minus the square root of 3 over 2, and we're in the same place. So being able to factor trig expressions or being able to treat trig expressions as quadratic-like things is important. Does anybody know what time we get out today? 2 minutes. All right, let's practice one more. 3 sine squared of x minus 2 sine x minus 1. Factor it. Bless you. Now, if it helps you, you can write this as 3y squared minus 2y minus 1 and factor it that way. And just replace your y's with sine x's, but you have to learn to be able to think in quadratic-like ways. This is a quadratic-like expression. It's in a quadratic form because we have 3 times something squared minus 2 times the something minus a constant. All right. You got it, Tate? What'd you get? Well, let's give it a shot.
I got 3 sine x.
Okay.
Plus 1.
Plus 1.
And sine x minus 1.
Sine x minus 1. That's correct. Yeah. Right? And then if this were an equation scenario, we could set that equal to 0. And then the sine x would be negative 1/3, or sine x would be 1. Now this is not one of our special angles, but we could use the inverse sine to figure out what that angle is. Where's the sine of x equal to 1? That's pi over 2, 90 degrees. Okay, so you can see where this skill is going to carry us over into the deal, into solving trig equations, not the deal. All right, we'll use it for